Hello again, guys. We are at the sixth day of the programming course that we started. Since now we are familiar with variables, input, output, the print and input function, and loops. And one more example of loops is multiplication table, which we are going to write it in a bit, and then we're gonna move onto something really different with all of the things we have already discussed. So let's dive in. I will comment all of the previous codes, and I can just kind of delete it. We do not need this. So for the multiplication table, first, just let's write one row. I was thinking about the row and column, and I just figured that maybe a column. Column is a bit easier. Just let's go for it. So for any x in a range of let's say 1 and 11, which gives us 1 up to 10, not the 11 itself. We're just going to print what we should print. We just going to print 1. Let's use f string. F string is this is the string. Let me just a bit zoom it. This double quotation is a sign for a string. So if we want to format it, we say f string, which is formatable. It's an abbreviation, and it lets you to use variables inside this string, so you don't have to concat anything. You can just say variable of x, or maybe the number of 1, whatever you're gonna say. So 1 times x equals to x. Let's just print this, and the result is 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4, and all the same up to 10. So 1 times 10 is equal to 10, and we're gonna just repeat this for other numbers. So I'm going to say for y in range of also 1 up to 11, and these are going to be 1 indent to the right, so they are now under the upper loop. And instead of 1, I'm going to write y times x equals to y actually multiplied by x. So if I run this, it's going to 1 times 1, 2, 3, and after the 10th row we are at 2 times whatever it is up to 10 and 10. But this is a bit ugly. I want to print a row instead of all the columns here. They must not be under each other, they must be beside each other. So at the print function, you can pass an argument called end, which means what should be the end of line. By default, it's /end, which means new line. So after each line has been printed, it automatically goes to the next line, because the end of the line is a new line. So I can just simply overwrite this and say end of the line is nothing, just whatever. And if I run this, everything is back together. That is not good. I'm going to use some spaces here. So my terminal is a bit uh, yeah, I don't have the space to doing that, so let's just reduce the length, yeah, that's going to be a bit easier. Let's clear it. Yeah, 1 2 and up to 4, because the range is all right. That seems reasonable. And yeah, but everything is horizontally. I can just use tab instead of some spaces by \t. It means a tab, which is a bit more disciplined. And after printing each row, I need to print a new line or nothing, and the end is new line, which new line is by default. I can just say print nothing, just goes to the next line, something like this. This is a bit this is more beautiful. And I mean, let's clear the console and see the output one more time. Yeah, this is promising, and all I need to do is just to extend this range by whatever I need. For example, 8, which goes up to 7. It's 7 by 7 multiplication table. And this is another usage of the loops inside loops, but this is not practical. I know, do not blame me. I just wanted to say, I just want to show the basic usage of each principle, and after a while we're going to stack them up together and build a real thing. Just be patient, and please write this by yourself and touch it on the tip of your fingers. You can just simply delete them after you were finished with them, but do not hesitate. Just start to write it yourself. So let's just get back. Another thing that we have already written is to detect if the number is prime or not. We just read a number, enter a number, whatever, and we did cast it to integer, and we assume that the number is prime, so we set the prime to true, and we will loop at 2 up to the number but not itself. And if a number was divisible by this I, which means it is 2, 3 or whatever up to the number not itself, a number before the number itself, and if it was divisible, we know this is not a prime number. And if it was prime, we were saying that you can use f string. You can say number is prime, or else print f string which says number is not prime, or compound, or whatever word you're gonna use for it. So enter a number, for example 34 is not prime. What about 33 is not prime, it is divisible by 11. What about 11 itself? 11 is prime. So this is working. And another thing about this conditional printing, you can just simply use that is too soon. Let's discuss it. There is a syntax in most of the programming languages which I don't know what it calls, but the signs are the question mark and colon. And you just write a condition here. If the condition was true, it's going to say true value, whatever it is, it's gonna return that, and otherwise it's going to return the false value. For example, you can just say age is not a proper word. You can just say print if age is it's greater than 21. You can say it's okay to drink, otherwise it is not allowed, whatever it is. Okay, you're gonna write a condition here and true value and false value here. But in Python, the syntax is a bit different. You can say it is okay to drink if age was greater than 21, otherwise or else it is not allowed. This is the same syntax, but in Python you're gonna use if and else keyword. So in this case, you can say number is prime if prime, else you can say the number is not prime, and get rid of this if and else block, and you can just simply use this one line printing with this syntax. And if prime was true, the printed value would be the number is prime, otherwise it is not prime. Let's see, what about 33 is not prime, what about 11, it is prime. So we have this little thing, and we can make it a bit faster. I mean, if you write a large number, it's going to divide every number in that list, and it's going to take a while. But at the first sight, you can just guess this is not prime because the number is even. It ends with 4, and the even numbers, I mean, there is only one prime even numbers, and that is the number 2, and all the even numbers except 2 are not prime. So at the first step, when the I is equal to 2, you can check that the number is divisible by 2, so it's not prime. So what is the point of checking other numbers? I mean, that is what is happening here. This is taking for long. I'm going to interrupt it, and simply for use our time better or making the algorithm faster, I can just break it here. The break command is actually breaking the loop, and it ditches the instruction that was doing at that moment, or the instruction that is at the queue for the end of the loop, and it ditches all of that and breaks the loop and goes out of the loop, and kind of passes it. So if I repeat that scenario with a large number ending with 4, it immediately says that it is not prime because it was divisible by 2, and after first checking that and setting the prime value, it's going to break that loop, and the loop is not taking whole, and the loop is not taking a lot of our time. So what about a large number ending with 3? It doesn't matter, because as soon as we hit a number that the input is divisible by that number, it's gonna say it is not prime and breaking the loop. So what about a real large prime number. So it's going to check it forever. Let me check for a large number, you know, a large prime number. I mean, let's see, large prime number. Okie dokie. Sorry about that. I found it, and it is largest known prime number, which has 24 million digits. I mean, I didn't mean that. Let's ditch it. Just simply ignore it. So imagine the situation that we're going to take two or three numbers, and we wanted to check if they are prime or not. So we just simply could copy paste our code, and internal number 12 is not prime, internal number 56 is not prime, again 12, 11, and it goes out because I just copied 4 times and it repeated our code 4 times. So we just know that this is not true. If we want to something that repeats 4 times, we can just say for I in range of 4 is going to count 0, 1, 2, 3, 4, 0, 1, 2, 3 only, which is 4 subsets or 4 times for repeating. And we didn't use that I parameter here. Oh, we actually used it. So let's say it is ki, whatever it is. We never used it, and it doesn't matter. It works, and it will ask for numbers and checks it. It doesn't matter. For the variables that doesn't matter, you can just say, you can just use an underline, I believe, and that's a convention. That's a non-written rule among the Python developers, which says if a variable was underlined, you can just ignore it because you're not going to use it. It was needed. You had to write something here. If we just delete this part, this is syntaxically wrong, and the Python interpreter is going to say we expect expected expression. It needs to be there. You have to introduce a variable at that part. So you just say underline. Underline is your variable, and this is not gonna be used. So what about you need another useless variable inside this loop? You cannot just overwrite the underline. You can just use double underline or triple, whatever you like. There is no limitation for how many underline you can use. So we just repeating this 4 times. What about we wanted to use this part of the code several ways in our whole project, and never wanted to duplicate it. For example, if there was a bug in this algorithm, you just had to replace it all over the places that it was used before. So to avoiding that, you can just define a function like the print input, whatever function that we have already used, and the sign of the function is having parentheses. We can just define it. I can just use define, or def is the keyword for defining. define is underline prime, and this is definition of the function named is prime. And I can say a colon, and the body is nothing, I just can pass. But in real world I'm going to use this one tab going to the right, which brings this code inside that function, and at the end a function needs to return the result. So if I use is prime, I expect to is prime returns something, or it could be an empty return, which we call it void, or it could be a boolean integer, what other data type that you're gonna use, it doesn't really matter. In this case I'm going to return the prime itself, which is a boolean. It could be true or false, and it determines the number is prime or not. But since I just moved my code inside this function, my function directly reads the value from the input. I should not do that. I have to take it inside the argument part. So these parentheses are actually the input of the function. You know, we just use print here, and inside the parentheses we provided the input. So we pass this sentence to the print, and we say just print this, and it just prints it. We don't know what is the body of the print. This is the whole point. So by defining this mini program called a function, I can just simply rewrite my program. So the number is internal number. I'm going to get it from the input and already casting it to the integer. And the prime, actually we don't have this variable inside here. This is now a variable inside the function, and the variables inside the function are separated from the original program itself. And there are some ways to connect them together, but right now they are separated by default, and we're going to let that be this way. We do not going to connect them right now. So instead of the prime variable, I'm going to call this is prime function and passing this number. Actually this number could be anything. I can just say it is I, and I just say I, and I'm passing I to is prime, and is prime is going to rename it to num and use it at this code and returns a value, and the value is going to be represented here. So the result of this prime is now has been checking in this if block. So if I run this again, this is working. 11 is prime, 12 is not prime. So everything looks fine, and everything is reasonably working. So another function, I'm just thinking about another function that we have already written. Yeah, like the perfect numbers. The algorithm of a perfect number is sum of the dividers must be equal to the number itself, but at the dividers we should not consider the number itself. So I'm going to define is perfect, and it's gonna take a variable named n, and I'm going to define a sum, and for any I in range 1 up to n, if n was divisible by I, I'm going to add the sum with I, and at the end, if sum was equal to n, I'm going to return true, otherwise I'm going to return false. So I can just use a shortcut for this. So if this part was true, return true. If it was false, return false. You can just simply return this part. I mean, return the result of this part. Okay, so now I have the is perfect, and I can just comment this and say print is perfect 6. We know already that 6 is perfect, and print is perfect 12. And if I run this script, it's going to true and false, because the 6 is perfect equals to true. I mean, this compression is true. Sum is equal to n, but for the 12, that's not the case. So the 12 is not perfect. So what is the use of defining two functions inside the program? If you ever wanted to discover which prime number is perfect, you can just use this code. So for any I in range of, say, 100,000, whatever, if the I was perfect and it was prime, print I. So it's going to check all the numbers up to 100,000 and check if it is perfect and prime at the same time. So let's run it and see which number is perfect and prime at the same time. 0 is not prime actually, but it is perfect by the definition. So we can see the 0 here. And I believe there is no other number that has two conditions so far. You can just wait and see what's happening here. This is going to do all the calculations, and this is going to take a while, because 100,000 numbers are not a little number of numbers, and the perfection check and the prime check is actually taking a lot, and this is the reason that we are stuck here and we have to wait to see the result. But there are some other ways to improve the speed. We are not actually going to talk about them right now. The solution are like the multi-threading, or the using the using the better algorithms for the functions. For example, for the prime number, you can just check true and half of the number, and the other half is not actually really matter, because there must be a number which is less than the half of the other number, and the number is divisible by that, something like that, which can speed up our code and make less steps to calculate. And yep, there was no other number. but if you wanted to check this without any function, it could be a disaster to writing those codes. So the functions are actually helping us to write a meaningful and readable codes to other, and we can just combine it and uh, use them wherever we want. So this was the contents that I was going to present to you at this episode. I wanted to introduce you to functions and what they do. At the next episode, we are going to see more exciting things about functions and how they are going to help us to solve the difficult algorithms uh, by just repeating themselves instead of using loops. That is called recursive function programming, and I hope I see you at that episode too. Have a nice day and bye for now. Take care.